I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, August 22nd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, not a whole lot's going on. A little bit of a portion of a gale, maybe producing 20-foot seas in the far southeast Pacific, but not even aimed to the northeast. And other than that, just nothing is happening. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, a push in the southern branch of the jet to the north. This is the southern branch here. This is the northern branch up here, and literally there are no troughs, so it's no surprise there's no gale activity in the South Pacific Ocean. Instead, the jet is falling to the south, ridging to the south, they say, down at about 67 south. The ice line is somewhere around 62 south, so the jet is pushing inland over Antarctic ice. No free and clear open ocean there at all until maybe you get far into the far extreme southeast Pacific, but outside of the California swell window. So there's no activity of anything here to be of interest. So we continue on looking Monday. If anything, the ridge starts pushing further south. And also note when you get this split jet stream flow like you have here, the northern branch up here, southern branch here, what you end up between the two flows is high pressure. And of course, that does nothing for generating meaningful swell. And that pattern continues. We're into almost Wednesday now, but then notice little bit at a time, the jet is forecast to start creeping north. And this is the beginning of a trough. What that sets up is a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, start generating seas. Seas, if they're large enough, as they radiate away from the fetch area, turn into swell. And of course, swell, when it hits your beach, turns into surf. All right, so we have a little bit of opportunity, maybe starting Thursday morning here. Winds in the jet about 130, maybe 135 knots, pushing to the northeast, and that's where you could get that clockwise flow aloft. And that is to continue into Friday, building over to the central South Pacific, and even Saturday perhaps, and Sunday making its way across the Pacific until we hit the 180-hour mark, and even then it's still present over in the far southeast Pacific, but another ridge is behind that. So it looks like there's some opportunity perhaps for gale development, we'll say Thursday through about Sunday. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, and as expected, no fetch greater than 35 knots, at least aimed off to the northeast. A little bit of fetch here, and we'll say in the Tasman Sea, but all aimed south at Antarctica, so no hope there. We're just looking, and that builds to 40 knots as we get into Monday, but again, all aimed south. Fetch has to be aimed at your beach to create meaningful surf. And so then we get into Wednesday, a little bit of low pressure starts building down here south of New Zealand. We know that there's a trough trying to organize, and there we go. As we get into late Wednesday night, early Thursday, 50 to 55 knot winds over a tiny little area here. There you go. Falling to about 40 knots. Under the tag, there's probably some 45 knot winds. Pushing off to the east, building area of 35 to 40 knot winds with a core down here at 50 knots Thursday night. Friday, kind of more of the same thing. You notice the fetch pushing pretty quickly off to the east as we get into Saturday. The cutoff for Southern California is about 117, 118 west. So once the fetch pushes east of there, then even Southern California is out of the window, and that's pretty much the case as we get into Sunday, and then we're into early Monday, maybe another little gale forecast here developing just south of Southern California at the 180-hour mark on the model. Of course, models more than about 3 days out. Don't take much stock in them. A week out, even less, but it's something to hope for. So what effect are those winds going to have on the ocean surface? Well, right now we know there's no meaningful winds, and of course, there's no meaningful seas. Oh, notice here's the ice line too. was that, about 62 south, maybe down to 64 south at one spot, but then up to 60 south. So pretty much, the peak of winter months down in the southern hemisphere. A lot of ice in control. We know that there really isn't supposed to be too much going on. Now, you see a gale here off of Patagonia, but outside the Southern California with swell window. A little bit of seas building to 20, 22, 24, maybe 25 feet. On Wednesday, south of New Zealand, but not really doing much. And then a little bit more meaningful fetch of seas to 29.9 feet right here. That's the high. This is the highest extent of seas over the area depicted in the image. Still not really a whole lot. Continuing at about the 28-foot level, building to 29 feet and 30 feet as we get into Friday, pushing across the South Pacific, then trying to redevelop, but mainly out of the Southern California swell window as we get into Saturday and Sunday, and that's kind of it. Pretty quiet indeed. So next up, let's just take a quick gander at the North Pacific. There's literally nothing going on except for, I guess it's Tropical Depression Linda. We have a little bit more data on this. I don't even know that NOAA is tracking it anymore, but it is approaching Hawaii, expecting to make an impact in the islands on Monday. We'll get into that more in a minute. We'll just zoom through and check out, looking for any signs of seas, even 20 feet. We see something here. What was that? It was 15-foot seas on Saturday. That's all wind swell generated, and we'll talk about that in a minute. Oh, and there we go, 180 hours out. So the northern hemisphere still sound asleep, a little bit early in the season. The best we've ever seen any sort of a semblance of a north swell was from a tropical system that sort of curved north on a semi-El Nino year a decade or two ago, and that arrived in San Francisco on like August 15th or 16th. So theoretically we're in the season, but practically we're nowhere near any sort of a major shift just yet. So next up, we start looking for wind swell, the potential for wind swell development. High pressure in control of the Gulf of Alaska, 1026 millibar, driving north winds at 15 knots along the northern California coast. I mean, I think there was some waist-high waves in the San Francisco Bay Area. Coming from the north at the most exposed north-facing breaks, but pretty minimal. Linda, again, approaching the Hawaiian Islands. We'll get into that in a minute. We have higher fidelity models we can look at. So we'll just go into Monday. Building fetch off of Northern California, 25 knots. That'll help create some wind swell. Of course, wind swell for Hawaii on Monday from Linda. Pretty much more of the same. Small wind swell for Northern California as we get into Tuesday. Residual fading wind swell for the Hawaiian Islands from fetch off the south side of the high. Wednesday, fading wind swell, if even manageable, rideable wind swell for Northern California with winds 15 to 20 knots there, and a generic 15-knot fetch pushing into the Hawaiian Islands. So maybe some meager wind swell on exposed east-facing breaks. Kind of more of the same. Junky 20-knot winds, junky short-period wind swell for California on Thursday, and kind of the same thing for Hawaii. Friday, the high starts building, moving east, pushing into California, heat low inland. The difference, the tightness of the isobars, given the closeness of these two competing low pressure and high pressure systems here, will generate some winds, theoretically 30 knots over Cape Mendocino, building wind swell where you really have nothing left for Hawaii. And then even more so on Saturday with 35-knot north winds off of Cape Mendocino and eddy flows south winds along the central and a portion of the northern California coast. So that looks like a promising opportunity for at least something to ride. Then Sunday, that fetch starts fading out, but still definitely producing some degree of wind swell down into north and central California. Probably not a whole lot for Southern California, and Hawaii pretty much out of the picture with a standard 10, maybe 15-knot easterly flow. All right, so tropical depression, theoretically it could be tropical storm Linda. 2 p.m. Sunday, this is the NOM model high res, focused on Hawaii. Winds in the gray right there, 35 knots, approaching from the east, targeting mainly Maui here. Oh, and this is an upgrade indeed. This is now showing 55 knot winds on Sunday evening, 8 p.m. Hawaiian time, but then falling back down into the, we'll say, 40 knot range. As we get into 2 a.m. Monday, here's Maui. Here's the core of this storm, just barely skirting the north side of Maui. All the fetch, the 40 knot winds north of the islands. Here's Oahu here, so Oahu is the target. Wind swell pushing towards the east-facing shores of Oahu. Notice the eye of the system actually pushing right through these islands here. Oops, how do we get that? There we go, right through there. Oh, and then racing off, and then moving, let's see, we have at 5 a.m. Monday, moving north of Maui, and then approaching Oahu, the core of the fetch, right up here, the eye of the storm. It's a tropical, it would officially be a depression with 35 knot winds, whether they upgrade or not, unknown. Here's the core now moving south of Oahu, 11 a.m. on Monday morning. Notice this right here, that is 30 to 35 knots sustained easterly winds pushing into the east-facing shore of Oahu. Probably gusts. If this were to actually happen, you could theoretically have 45 knot gusts and a good amount of rain. All the energies on the north side of the system. So Oahu to get probably a pretty good dose of rain, though short because the system's moving off by 2 p.m. The eye or the core of this depression already passing Oahu, the fetch settling down. So this is what, maybe a 3-hour event. By 5 p.m., it's already the eye's gone past Oahu, fetch settling down. Wind swell on east-facing shores indeed. 6 foot, maybe 7 foot at 8 or 9 seconds, something like that. So purely a wind swell event, a kite surfing event, I guess, if you're willing to do that. And then fetch moving over Kauai Monday evening, and then out of the picture beyond that. So not a big event, but if you're on the east-facing shore of Oahu, maybe even Maui, take some minimal precautions. Bring I don't know that you would need to board up your windows or anything like that, but just things that get blown around by the wind, deal with that, and prepare for some rain too. But again, since it's moving so fast, not a particularly soaking big event, at least according to this model. Back to the Sierra, California, looking for any signs of cooling temperatures in the upper atmosphere here. This is located at Squaw Valley. The reds are above freezing temperatures. The yellows are what we consider sleet, about 34.5 degrees or lower. So you see a little bit of dip in the elevation of the freeze line. The whites is 32 degrees Fahrenheit. So temperatures, the freeze line falling to 13,000 feet on August the 24th, and by the 25th, we're back up above 14,000 feet. So no clear signs of any change in season or any significantly cool air moving into the area for the next 10 days. And with that, let's go off, take a look at the long-term outlook. What's going on with the Madden Jullian Oscillation, that periodic oscillation? It has an active phase and an inactive phase. Either one of them takes about 4, maybe 5 weeks to traverse the Pacific. From west to east, they both rotate opposite each other around the planet on the equator, moving from west to east. The active phase supports gale formation, feeds energy in the jet stream, can create Kelvin waves, which can be a precursor to El Nino. The inactive phase basically is the opposite. It's high pressure, where the active phase is low pressure. The inactive phase is like a high pressure system, steals energy from the jet stream and does exactly like what we see. The jet stream in the southern hemisphere falls south, or in winter months it pushes to the north, and you don't get really any good support for storm formation. So let's go dig into the details. So the first part of this discussion is about the MJO. We're looking again for that active phase over the Pacific. That'll give us sort of a 4 to 5 week lookout as to what's going to happen. swell, for the improving the probability for storm and therefore swell production. Right, so we're looking for signs of the active phase. First off, we look at buoys. It's always on the equator. The MJO moves from west to east on the equator. So we happen to have this nice chart here that shows wind speeds, data from the TAO buoy array, a series of buoys strung across the equator, used for monitoring El Nino. They also have wind sensors on them. We get 5-day averages from that, so it's not winds like right now, but it sort of gives you this smoothed out view of what's going on. We see winds, the length of the arrow in the direction, the longer the arrow, the stronger the winds. Pretty strong out of the east, trades over the East Pacific. Same deal, say moderate to strong over the Central Pacific, and moderate to strong over the Kelvin wave generation area, this area in the far West Pacific. Again, 5 degrees north and south of the equator, from 135 east to about 170 west. When the active phase moves over here, it can stomp on these trades because it's low pressure, and that can actually reverse trades, and that can create a Kelvin wave. That can also impart energy to the jet stream. But it is not the means that we're so interested in. It's anomalies, differences from normal for this time of year. Are these strong easterly winds typical in the East Pacific this time of year? Well, you just go look at the arrows here and you see, well, seems pretty much neutral, maybe a little bit stronger out of the east, but not much over the East Pacific. Central Pacific, yeah. Oh, actually, I'm sorry, that was a westerly anomaly there, but pretty much neutral. Same pretty much over the Central Pacific. Over the Kelvin wave generation area, a little bit stronger out of the east than normal. That would probably suggest stronger than normal trades, which suggests the inactive phase of the MJO, that portion of the MJO that really isn't great for storm production. And again, that's no big surprise. We looked at the jet stream models earlier, and in the southern hemi they had the jet stream ridging far to the south. So that's an indication that nothing normally above normal energy levels were not present in the jet stream in the southern hemi. So probably a good sign of the inactive phase of the MJO. Let's go look at the forecast. Next up, 850 millibars zonal wind anomalies. So that's zonal means the east-west component of the wind. Are the winds stronger out of the east or stronger out of the west? Okay, we don't care about north and south. It's that east-west thing that helps create Kelvin waves and impart energy to the jet stream. So the yellows and oranges are westerly anomalies, typically associated with the active phase of the MJO. The blues are easterly anomaly, enhanced trades, typically associated with the inactive phase of the MJO. Right, this is the whole planet on one chart. The date line, the international date line, 180 west. Okay, so right there. The far western extent of the West Pacific starts about 135 east, right about there. Okay, and the east extent of the Pacific is about 80 west where Ecuador is, so right about there. So the Kelvin wave generation area, 135 east to about 170, so right in that box right there. That's today's winds. You see easterly anomalies in control. Forecast, unchanged, maybe building slightly over the next 7 days. Each one of these tick marks is a day. So for the next week, pretty much no change in where we're at with the jet stream displaced pretty far to the south. But we do know that perhaps there's a change forecast with the jet lifting a little bit to the north and building a trough. So this is not a guarantee of anything. It just gives you sort of the general trend, the hint of where the momentum's going. All right, so let's go look out 2 weeks. Now, this is outgoing long wave radiation, cloud cover. Again, the MJO in the inactive phase is like high pressure. High pressure typically doesn't support clouds, clear skies. Clear skies on this image look like oranges and yellow, a lot of sunlight reflecting off the ocean surface. Right, so where are we? There's the equator right there. There's South America, Central America, Galapagos, Hawaii, New Guinea there, Kelvin wave generation area. There's the date line, 180 west. So in this box roughly right here. So we see today, this per the statistic model, a fair amount of sunlight reflectivity off the ocean surface, meaning high pressure, meaning the inactive phase of the MJO. You can pretty much see what the trend is for the next 15 days. Building inactive phase for the next 2 weeks per the statistic model. Now, the dynamic model, interestingly, is a little bit different. It says, yeah, the inactive phase to sort of hold where it is, maybe build a little 10 days out, then collapse 15 days out. So a little bit of difference between the two models here, but mainly it's these first 3 days here where the statistics suggest stronger inactive phase, the dynamic not quite as strong. Next up, phase diagram charts. All right, so this is another way to look at only the active phase of the MJO. This is mapping the inactive phase. The MJO moves from Indian Ocean, west to east, over the maritime continent like Bali, to the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so it's in the Indian Ocean today. And the further that heavy dot right there is away from this circle, like out in here, the stronger it is. So this would say a very weak active phase of the MJO in the central Indian Ocean today. And here's 1, 2, 3 possible tracks. We'll go with 2 of them suggesting the active phase remaining weak, moving to somewhere around the maritime continent, maybe the West Pacific, 2 weeks out. This per the statistic model. The dynamic model, not even that encouraging, just suggesting the active phase noodling around and ending up about where it started 2 weeks from now. So no real, what you really want to see is that heavy dot. Where is it? Right there or right there. You want to see it like up here. When you see that, then you know you have a strong, very strong active phase in the West Pacific that is with a high probability of creating a Kelvin wave. And typically when you see that, you're in some sort of an El Nino pattern. But clearly, we're not there right now. All right, a 40-day model now, okay? Another component of the MJO is precipitation. So this is up at the 200 millibar level, but basically showing you dry areas of the planet that are drier than normal or wetter than normal. The dry areas, one can assume, is the inactive phase, the MJO. The wetter areas are the active phase. All right, so how do we read this? So there's 8 different panels down here. Each of them is about 5 days in duration. There is South America, Central America there, the equator right there, date line roughly there, that one little dot right there, that's Hawaii, the Philippines, New Guinea, Kelvin wave generation area, that's what we really are interested in. That's where all the energy transfer happens, is right in there. So right now, neutral pattern of the Kelvin wave generation area, inactive phase, dry air, moving over Central America. You can see inactive phase moving into the Atlantic through about September 11th, and a very weak active phase trying to set up in the early part of September, making its way across the Pacific through the end of the model run. That's the 1st of October. And about that time, notice the inactive phase here in the Atlantic, then coming back over North Africa. There's 0. Actually, it's more like Central Africa. And through the Indian Ocean, and then bound back to the West Pacific. So this is a 40-day, so that's, what's that, about 5 weeks. So maybe 6 weeks to go from the inactive phase, to go from Central America back the whole way through, around the planet, back and to the same place. So again, that sort of 5-6 week cycle, if you will, from wet to dry, on. You follow that and you get a good sense of when you'll get storms. When the active phase is over the West Pacific, that's when you get energy transfer to the jet, and that's when you get storms, either in the north or southern hemisphere. And of course, that in turn produces surf. Next up, the 1-month Cfs model. This is 850 millibar winds. Again, the east-west component of the wind up at the 850 millibar level. That's about, 4,700 feet, something like that. So, but that's a good proxy for what's going on down at the surface. Today, whole planet on one chart. Where are we? Date line right there. Okay, the West Pacific starts about 135 east, so right there. Kelvin wave generation area ends right about there. This is the box we're interested in for energy transfer into the jet stream. Right now, the blues, easterly anomalies, inactive phase, sort of a mixed pattern after that as we get later into week 1 in August. But then that fades out according to this model, which is different than the other one was suggesting, with East Anomalies building inactive phase of the MJO taking over pretty much the first half of September. These the black contour dotted is inactive phase. This is the active phase. This is over the Indian Ocean. But one could assume that somewhere down here, maybe later in September, the active phase moving into the Pacific. So maybe not too far off the mark from the other model. All right, now this is where things get kind of interesting. This is the 3-month CFS model. Again, 850 millibar zonal winds. Past performance is down here. The forecast is up here. Kelvin wave generation area, I'm looking around the microphone here, starts about 135 east, so right in here. Going to, there's the date line 180, so going to 170 west, so right in here. What you do notice is a bunch of blues, but we also see a sort of a yellow-orange pattern setting up. Yellow and oranges, westerly winds moving from the Indian Ocean to the Pacific. Easterly anomalies pretty strong in the September, early October time frame, but then maybe giving up some sense. So to me, this looks like the active phase, maybe trying to get a foothold in the Kelvin wave generation area, second half of September, and then filling the Pacific, maybe as we get into early November. That's a good thing. Let's overlay the MJO. All right, the dotted contours are the inactive phase. The solid contours, the active phase. And again, the area we're looking is from here to about here. All right, so today, that's where we are right there. Inactive phase of the MJO, easterly anomalies in control into about September 15th. But come September 15th, and the models have been pretty solid on this, suggesting a cohesive, broad, and decent active phase of the MJO setting up. Now, the details change from day to day, but this is pretty much what it's been. This active phase setting up September 15th and staying in the Kelvin wave generation area almost till mid-November, something like that, with westerly anomalies in control. That's looking pretty good. But then you see inactive phase forecast. That's like 3 months out from now. Don't know that I believe that, but pretty solid at that point in time. This is all pretty much what the model has been showing for a couple of weeks now. The new and interesting piece that just showed up today, and I'll walk you through. This is the low pass filter. Sort of shows your high and low pressure bias, okay? Low pressure bias here is already passed. It's in the Indian Ocean, maritime continent. Okay, it's gone. High pressure bias, which last winter was 1, 2, 3. It was actually like 5 contours deep. This would be high pressure over the Pacific Ocean. It's got about another 7 days left, and then it's gone. And then you go into this funk of nothing. And this model had been projecting the high pressure bias rebuilding like it is here, but much stronger with up to 2 contours and like filling the dateline area. Today, the model just shows it as this little blip that kind of goes from, we'll say, mid-September to early part of November and then just disappears. And the low pressure bias was forecast building stronger over the Indian Ocean. Now it's just sort of like a hint of it. It's there, but not very strong, not nearly as cohesive as this sort of thing here. Again, one day of a model run does not represent a trend. I wouldn't take this to the bank or anything, but the model is, at least for the moment, suggesting some weakness in what was to be a building La Nina pattern. It's suggesting that, well, maybe it's not really going to be. I mean, this is not a La Nina. A little bit of high pressure for 2 months, we'll be generous and give it 2 months, is not La Nina. It would be maybe a slight return of something that sort of smelled like La Nina, but by the time you start to smell it, it's gone and dissipates. So maybe just a neutral pattern, at least from a pressure perspective in the Pacific this winter. That said, let's go even further out into the future. Look for some signs of this El Nino, La Nina thing as we get into late fall and winter. All right, so how do we do this? We're going to start by looking at water temperature, subsurface. Right? Major component of El Nino or La Nina is the balance of warm and cold water down at depth in the Pacific. We're looking for Kelvin waves or the development of cold water. So again, data from the TAO buoy array. These are the anchor lines, these X's here, that are holding the buoys in place. The X's themselves are the sensors on those anchor lines. They collect all that data, send it to a central processing facility, run it through a model, and you get sort of a view of the balance of warm and cold water in the equatorial Pacific. Warm water, 29 degrees here, the reds. That's 29 degrees centigrade in the West Pacific. 28-degree isotherm. It's at 171. I think it was over about 168 last week. So it's backtracking a little bit. The 24-degree isotherm was somewhere around 125. It's backtracking to 134 west today. And then a much shallower pool of warm water over in the far East Pacific. But it is not the actual water temperatures, it's the anomalies again. Differences from normal for this time of year. We see slight warm water in the West Pacific, 1, maybe 2 degrees above normal, holding at, what is that, 150 west, so that'd be about south of Hawaii, and we don't think that's going to move anywhere. If it were to be moving off to the east, that would be a Kelvin wave, a ball of warm water traveling under the ocean surface. Takes about 3 months to go from the West Pacific to the East Pacific, and typically would be driven by the active phase of the MJO reversing trade winds in the far West Pacific. We don't see that. We just see a ball of warm water sitting stationary. Dead to, I don't even want to say neutral, it's below 1 to 2 degrees below normal. Cool waters in the East Pacific, and maybe a little bit of hangover of warm water here in the far East Pacific from 2 Kelvin waves. We'll show you that formed months ago, and they're all but fading out. Another model using the same data, a little bit even starker depiction. Warm water brick walled up about 160 west, making no eastward progress. This actually looks like a Kelvin wave, but there hasn't been there hasn't been an active phase of the MJO with enough westerly anomalies associated to give a Kelvin wave any momentum. So it's warm water just sort of balled up here and going nowhere. Cold water in control of the eastern half of the Pacific and making its way up to the surface, a cold water Kelvin wave, if you will, typically associated with La Nina. Sea surface height anomalies, so South America here, that's the Galapagos right there. Oh, equator, there's the equator. There's the date line right there. Central America, Mexico, Baja, Hawaii, New Guinea right there. Kind of a strange looking map. But what we're looking at is so this is data from the Jason-3 satellite. Rotates around the planet. It goes in a circle, and the planet rotates under the satellite. So you get swaths down the planet, and eventually you get the height of the ocean around the entire planet after a couple of days of, I don't know exactly what the duration is, but we'll say 3 or 4 days. You get a pretty good swath of ocean heights. That is, strip out the waves, strip out the wind waves, strip out the tides. And is the sphere of the ocean higher or lower than normal? All right, you see -5, -10, -15. That's 15 centimeters below normal, which, what, that much or something like that? Not a whole lot. Okay, cold water contracts. When it contracts, it leaves a divot on the ocean surface if you have enough cold water depth. We know, or at least the other charts we were looking at showed a lot of cold water here on the equator. There's the Galapagos in the East Pacific. This confirms that. And then we see above normal 5 centimeter anomalies in the West Pacific. That is, warm water expands, pushes the ocean up a little bit. Also, if you have stronger than normal trades here, they're scooping out water here, pushing it off to the to the west, creating that bulge there. A quick look at currents. There's the Galapagos, so maybe we can just drag this a little bit. There you go. So Ecuador would be right there, the Galapagos there, Central America. Trades driving this current pretty good off to the east. We'll continue our way across the Pacific here. Give it a second. There we go. The whole way across the Pacific here is, we'll get into New Guinea right there. And you can see trades pretty much in control. When you have, maybe we can back this off a little bit. There you go. We'll try it that way. When you have El Nino, you will see this current actually switch direction, turn from west to east, driving warm water across the Pacific this way. But instead, no, we have, this is where typically upwelling is. Trades are strong along here. Nutrient-rich water pushing its way west across the Pacific. The trend over time. All right, September 2020. The oranges. This is just upper ocean heat anomalies in the Pacific. Warm temperatures in the West Pacific, cool temperatures in the East Pacific. Peak of La Nina, characterized by colder than normal water. This was right around Halloween last year. Then we see a active phase of the MJO set up in March, producing westerly anomalies to tap this warm water, produced Kelvin wave number 1 that pushed across the Pacific. Kelvin wave number 2 by another active phase, we'll say in late March, early April. Kelvin wave number 2. A third weaker Kelvin wave in the late May, early June time frame. And then you notice the warm water pool in the west pretty much tapped out. Trades started redeveloping. Cool water in control right now. And we expect nothing different for the next several months. Upper ocean heat anomalies for the area from the date line off to 100 west, so a bit off, let's say the Galapagos roughly. You can see we've been cold September, October, November of last year. The whole way up until March, the balance of temperatures got warmer. March, April, May, June, and July, and now we're falling back off the cliff, down 0.8 of a degree below normal over that whole area, and we don't expect any difference for a while. So let's go look at the ocean surface, what is going on. And again, we're only focusing 5 degrees north and south of the equator in the Pacific. It's really amazing, that one little area just on the equator, just, was it 5 degrees north and south? So that's 300 miles north and south of the equator. That can dictate the jet stream and weather patterns over the entire planet in the more extreme cases. So right now, Ecuador's here. Warm water off of Ecuador, the Galapagos right there, but only making it to about, what is that, about 110 west, south of Cabo San Lucas, let's say. Then cold water in the official El Nino monitoring region, the area from 120 west to about 170 west, where is that, about right here, 5 degrees north and south of the equator. So this would be the Nino 1.2 region. This is the Nino 3.4 region. And then the Kelvin wave generation area is off beyond here. Yes, we see cooling off of California. Again, core of high pressure. You look at hot water there. Yes, that's true. It is warmer than normal for right now, north of Hawaii. High pressure. But that also means strong high pressure has just been locked here endlessly. The flow around high pressure is clockwise in the northern hemisphere. The outflow, the trade winds from that high, cool water north of the Bay Area, San Francisco Bay Area, creating upwelling there to a point south of Hawaii. This actually faded a bit last week, but it's making a bit of resurgence this week. So all this is not really, it's sort of a mixed bag with warm water here, cool water here, but probably siding more, especially in the southern hemisphere, with this large area of cool water south of the equator, siding towards La Nina. The trend for the past 7 days, actually warming here in the East Pacific on the equator. Oh, that's, again, Peru right there, Chile, Ecuador, Central America, South America, Hawaii there. Equator running right along here, 0. Dateline right here. And cooling south of Hawaii. This is the Nino 3.4 region right in here. So on the balance, cooling, but this is just a 7-day trend. So we're kind of, 7 days is not much of a trend, but we're looking for any glimmer of hope and trying to tease out anything that can give us a sense of where we're headed. And then the broad overview, again, the same thing. Mainly right here, a little bit of warming. That's not much. The main area that matters right out here is all cooler than normal temperatures. This is sea surface temperature anomalies, differences from normal for this time of year. So cooler water out here, warmer water here, and then this stuff up here really doesn't matter. It's here on the equator. That's the main indicator of where we're heading for the future. Sea surface temperature anomaly trend in the Nino 1.2 region, the area right up there in the East Pacific. So we were near neutral in June into July, early part of August. Temperatures have dropped. We're what, 439 thousandths of a degree below normal, so just a bit above half a degree above normal. And this cooling trend, still, it's not super cool, but it's not warm either. The official El Nino monitoring region really paints the picture here. Since about the beginning of July, temperatures have been on a steady, slow downward trend, 369 thousandths of a degree, about a third of a degree below normal. You got to be half a degree to be La Nina, either for 5 consecutive months, either negative or positive above normal. So theoretically, we are still officially in a normal regime, but we suspect that this is going to continue to fall towards the negative as we get towards fall. So we've talked subsurface temperatures. We've talked ocean surface temperatures in the equatorial Pacific. What's going on in the atmosphere, right? If you have more evaporation, if the ocean is warmer, you get more evaporation. That adds energy to the jet stream. That sort of feeds things. But if you have cooler temperatures, well, that suppresses evaporation. That helps set up high pressure, and that's what pushes you towards a stable atmosphere, which is exactly what we don't want if you're looking for rain, if you're looking for storms that produce surf. All right, so we look at the difference in pressure between Tahiti, which is in the West Pacific, and Darwin, Australia, which is roughly in the Indian Ocean, we'll say maritime continent. If the index is negative, today it's plus 3.46, but if it's negative, then we could say, okay, well, there's lower pressure over Tahiti, and that's exactly what we want to see. That would be like an El Nino, or at least the active phase of the MJO. But looking down at the daily numbers, we've had 1, 2, 3 negatives, a smattering here and there, but a whole lot of positives too. All right, but we'll average that out. That's kind of a noisy number. 30-day average, plus 3.91. The good news is it's down from like 4.58 and down from 10.45 or 10 up to, you see there. We have been on a steady downward trend for the 30-day SOI, almost approaching neutral, but not quite there. So that's kind of good news. The 90-day average, this is your El Nino La Nina indicator. Today, 5.28, plus 5.28. Where was it? It was up to maybe 7 at one point. So kind of neutral, biased, positive, not in La Nina territory. I think this was up at plus 15 at the peak of La Nina, and this was up at plus 19. So we're in a lot better place than we were, but also remember, we're just coming off of multiple Kelvin waves and active phases of the MJO, and there's sort of a sense that we're moving into maybe a slightly higher pressure regime as we get into the fall, but the model run there wasn't not looking nearly as strong and decisive about this La Nina as it did even a week ago. Again, it's only one run of the model, but we'll keep our eyes on that. Here's a look at the 30-day moving SOI average, sort of graphed out. So you can see back in 2019 we were negative. El Nino, weak El Nino. And then in 2020 we started moving positive. These are the active phases of the MJO, these downward spikes. The upwards are the inactive phase. You can see the trend was towards the balance of active phases of the MJO. And then in April this year, pretty good solid active phase of the MJO created those Kelvin waves we were talking about. But now we've just come off a big inactive phase, moving towards the active according to this, but we're not really seeing any signs. until, when was it? September, October, later in September, a big inactive phase is supposed to set up. We'll see if that is able to drive this thing to neutral or down into negative territory. If that were the case, and we would expect that maybe it would be, that clearly then we'd be through the end of La Nina. So finally, the El Nino La Nina forecast. Where are we? Well, we're going to look at surface temperatures in the Nino 3.4 region as forecast by the CFS version 2 model. Pretty good model, probably the best of them in our estimation. So we got our sea surface temperatures. This is neutral right here in the Nino 3.4 region. About neutral in June. We've been at the solid line here is actuals, so we're down about 0.4 of a degree below normal. This model suggests we're going to minus 0.9 of a degree, almost 1 degree below normal as we get into late October, early November. Then a steadily rising trend from there. But this version of the model has some issues. They do a PDF corrected. I'm not really sure what the PDF corrected part stands for, but it sort of takes out some of the inherent biases in the model. This one suggests 0.75 of a degree below normal in the fall time frame, and then rising from there. 0.75 of a degree, and you have to be 0.5 degree below normal for 5 consecutive 3 months. So let's say October, November, December, January, February. That would qualify as a minimal La Nina right here. There was our stronger La Nina back last year. So a minimal La Nina from a sea surface temperature perspective. From a high-low pressure bias, maybe not as bad as this suggests. So for right now, there is no swell in the water other than expected wind swell, but perhaps a small gale to develop south of New Zealand on Thursday, Friday, Saturday. That's almost a week from now, 5 days from now. And traversing the South Pacific, maybe some small sideband southern hemi swell to result. But typically, we're in that starting to move into that time of year now where the South Pacific starts warming up, moving towards their summer, and the storm machine sort of shuts down. We're waiting for the North Pacific to come online. We're seeing no signs of it at this time. So typically in the shoulder season, you get wind swell, you make the most of it, and you pray that something wakes up in the North Pacific. We're not expecting that to happen anytime soon, given that we're in this kind of La Nina pattern and high pressure is very dominant in the Gulf of Alaska right now. So we're just going to have to gut it out. The good news is looking out, active phase of the MJO, pretty solid on the chart starting early September-ish sort of thing, mid-September, and going the whole way through October, maybe in November. That would be your big red X for when there'd be surf, and that sort of fits pretty nicely with the start of fall. So this maybe 3 weeks, 4 weeks here where things are just going to be kind of meager. We're going to have to make the best of what we've gotten. That said, pretty good run of southern hemi swell did happen the past week, and there's even a little one before that. So it's not like we haven't had surf. I hope you were able to go out and get some of it. We certainly did make the best of it. And then looking beyond that, the model's a little bit ambiguous about the strength of La Nina, but they seem to be moving more towards a weaker La Nina than previously expected for this coming fall. That would be good. At least maybe we could sneak in some storms and get some significant class surf out of that. And but it's still, again, we're in August, late August, and we're trying to predict the surf in Thanksgiving and Christmas. So quite a few months out still, but again, we're going to try to push it, make the best of it. It looks like there is some opportunity though, so all hope is not lost. All right, if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe, ring the bell. Comments, always welcome. If you have questions, you don't understand something, just put it in the comments there. We'll reply, try to get back to you pretty quickly. And if you don't want to subscribe, that's okay too. You can find the forecast, the video forecast. The link will be at the top of every page of stormsurf.com. That's where all the data that you saw tonight is available at. You can peruse the pages, dig through the website, look at the wave models, buoys, all kinds of stuff. You can dig down all sorts of rabbit holes and get very geeky in trying to understand your surf and where it comes from and how strong it is. All right, so that's it for this week. We will do it next week, same time, same channel. Thanks for watching. See you then.